This is Economics PowerPoint Lecture 6 on utility and utility maximization. Let's learn some economics. Now we arrive at the most, to me, a disturbing thing. I'm a quantitative kind of guy. And I find utility the most disturbing because it is, when all is said and done, the most difficult to quantify. You wouldn't learn that. You wouldn't come up with that reading economics textbooks, because economics textbooks make it seem very objective, very quantifiable. But in point of fact, it's not. And let's look at why it's not. But nonetheless, once we do that, we'll look at some of the derivations of it and see where we can go from there. Utility, very simply put, is the benefit gained from consumption of a commodity. What we were talking about in, I think, PowerPoint Lecture 1 or 2 as use value. Okay? Now, we've been working a little bit, and we'll continue to work with it as we go through supply, with the idea of total versus marginal. And it's really simple to understand the distinction between the two. Total is the sum of all the marginals. Marginal is the change in the total based on a 1 unit change in whatever that variable may be. And so when we're talking about utility, which is the maximum benefit gained, okay, we have a total utility, which is the total benefit we gain from the consumption of a commodity. The marginal utility is the amount that's going to change based on a 1 unit increase in our consumption of that commodity. Okay, and we'll clear that up as we go along, because we'll be using total and marginal as we go along, really for the remainder of the semester. Okay. Now, this is critical to understand, okay? And there's a few different things that we want to think about with it. And so let's just throw it out there first, okay? Diminishing marginal utility means that each successive unit consumed yields less utility than the preceding unit. What does that mean? That means, among other things, the more I consume something, the less valuable each of those things is, okay? Which means, ultimately, the more I have of something, the less valuable each of those is. Okay. Now let's look at just kind of a utility table. And this is what troubles me so much about utility, is that utility is ultimately an extraordinarily arbitrary measurement. To put any numerical value on it whatsoever is an arbitrary measurement. Nonetheless, we attempt to do this. Okay, so here we have an example of the utility gained from the consumption of a large order of McDonald's French fries. I love McDonald's fries. Every once in a while, I get this hankering for McDonald's French fries, about every 6 months or so. Okay, and what do we see? Okay, we see, modeling our law of diminishing marginal utility, we see the marginal utility gained with the consumption of the first unit, the first order of a large order of McDonald's French fries, is 10 units, whatever that 10 units might be. Okay, now let's look at the relationship that I was talking about between total utility gained and marginal utility gained. We gain 10 from the consumption of the first. We gain 9 from the consumption of the second. Notice that the marginal utility is diminishing. Well, that gives us a total utility gained of 19. We then gain 7, which will give us a total utility of 26. You'll note the difference in the total utility is equal to the marginal utility gained from the next unit. We take in a fourth order, that's going to give us 5. The total of 31, all the way down. Now, notice some of these things right here, okay? It is possible, and I suspect that we have experienced what would be called a negative marginal utility. Okay, for example, I'll give you an example. It just happened in class today. I did my on-ground geography today, and one of my students came waltzing in with something they'd bought downstairs at one of those multitudinous Parkhurst establishments at Romo's or something like that, and it was a key lime Greek yogurt. And I could tell when she opened it up and took her first spoonful of the yogurt that she had received from that spoonful, to her surprise and utter horror, a negative marginal utility, because I could see from the look on her face that she just did not enjoy it at all. Okay? Well, that's negative marginal utility. That's happened to us all. Okay? What we see here with marginal utility, and in the example of the McDonald's French fry, okay, and I don't know how you feel about McDonald's French fries, but about every 6 months or so, I get the hankering for them. Okay, and I swallow my pride, and with great embarrassment, go into the McDonald's. And let's face it, going into a McDonald's is usually a fairly embarrassing situation, because I mean it really is a kind of a symbol of the depths to which I as a cook have sunk when I go into a McDonald's. It's a little bit better now that I have grandkids, because I can walk into McDonald's with my grandkids and not have to face the shame, because I can say, oh, well, I'm not here for myself. I'm not here I'm here for the kids, you see. Because, and that's fine. That's fine. But when I have my, and even if we can actually even think, this is, another of the difficulties that we have with utility is, when you talk about the consumption of an individual unit, well, what are you talking about here? Are you talking about a large order of McDonald's French fries as an individual unit, which is what we've talked about here? Or are you talking about an individual French fry? This is why one of the more ridiculous things that I see is on all food commodities, they have what do they have? What do they call it? Serving size. Okay, well, do we consider that a unit of a commodity that's consumed? And the serving sizes are always ridiculous, because, like, if you look at Oreo cookies, okay, have you ever looked at the serving size on double stuffed Oreo cookies? The serving size is 2 cookies. 2 cookies. Who eats 2 Oreo cookies? Okay, for me, the serving size of Oreo double stuffed cookies should be sleeve. I mean, I eat the entire sleeve. Otherwise, it's just not satisfying. But at any rate, yet another of the problems we have with utility. Okay, when I begin to consume them, okay, I really enjoy them. They're like wonderful. They're like these little golden rays of sunshine that I take into my mouth, and it lights up like a rainbow the entirety of my being, and I swallow it down, and it's just so yummy and good. And the second one too, not as good as that first, but still good. Well, as I plunk through my large orders of fries, by the time, and literally when I go in there, when I have this hankering for French fries, I go in and I'll get 4 orders of large orders of McDonald's French fries. And by the time I'm done with the first one, when I'm about midway through the second one, I really start to experience diminishing marginal utility. Okay? It's been happening all along. I'm enjoying each successive fry less than the previous fry. But by the time I'm midway through the second order, I can't stand the things. And yet I'll continue to consume them until by the end of that third order, I'm down here getting negative. I have no idea why I'm consuming this. It's just some sort of bizarre addiction that I need to finish. Okay, I guess we were all trained that. I was trained that way when I was a kid. You have to finish what was on your plate. You have to finish whatever you've ordered. Okay, so I'm finishing this, and I'm just receiving negative margin utility. Now let's look at what that looks like on a graph. I start out with my consumption up here. Each unit I consume drops me down until I reach that point where I just can't stand the thing anymore. At which point it goes into negative numbers. Okay. Now let's look at the graph of marginal and total utility. Okay, here's that marginal utility we just looked at. We start off here as we consume successive units. Each unit yields less than the preceding unit. We're going to see an antecedent to this when we deal with supply, called diminishing marginal returns, and we'll talk about it at greater length then. It's the same basic idea with one tiny tweaking of it. Okay, now let's look at what total utility looks like as a result of that. Okay, I consume my first unit. As I consume each successive unit, it yields less utility to me until I go into negatives. What that looks like here is, okay, I consume that first unit, that gives me this total utility. Each successive unit yields me less, and so it's going to be a parabolic curve that will ultimately, as I consume more and more units, the curve gradually flattens out. And the reason it dips down, of course, is because at some point I'm receiving negative marginal utility. That's not universally true. Okay, it's not universally true that as you consume successive units, you're going to ultimately receive negative marginal utility. It's an extension of what we've said about diminishing marginal utility. Okay, based on what we've said about diminishing marginal utility, since it's diminishing like this, we can extrapolate from that the relatively logical conclusion that eventually it will go negative. That's not necessarily the case, and so we don't add that into the law. What we have as the law is that each successive unit is going to yield less than the preceding unit. Okay. Now, I like this way. The book relegates the discussion of this to the appendix to the chapter. I kind of like this method better. And the reason I like this method better is because of the logical conclusions that can be drawn from it, and because we're not attempting here to attribute an absolute quantitative number for the measurement of utility, okay? Because ultimately utility is a subjective thing, okay? The benefit gained by one consumer, the benefit gained of consuming something is different than another consumer, okay? And so it's very difficult to attribute an actual number. We're not doing that here. In an indifference curve, what this means is, let's look at products X and Y. Okay? If you like, we can say McDonald's French fries and anything other than McDonald's French fries. This is really based on Aristotelian logic. We'll see it a little bit later on, where we have X and we have not X. We phrase them as X and Y here. Okay? These are different combinations, okay, of the products that will yield me the same utility that I find to be of equal benefit to me. Okay, so I can consume 18 units of X and 5 units of Y and get the same utility overall, the same total utility as consuming 5 units of X and 10 units of Y. Less X, more Y, okay? I suspect, ultimately, it depends on my mood. It depends on what I want at the time, okay? And so these are combinations of products that yield the same utility. Hence the name indifference. I'm indifferent as to which of these combinations I choose, because these combinations are going to ultimately yield me the same utility every time, okay? So that 12 units of X and 7 units of Y, 12 units of X, 7 units of Y, yields the same utility as 3 units of X and 13 of Y. All right? Now, as is our want as economists, we economists are all ultimately frustrated artists. We want to draw this on a graph. Okay? And on this graph here we have quantity of product X, quantity of product Y, and we see that this is drawn directly from the table. We see the points in here. Here's point G, where we're consuming 18 X's and 5 Y's. Goes all the way down to A. Okay? We go up the curve like this. And so an indifference curve is kind of isometric. It bows like this. Okay? We're going to see something similar when we get to supply. But for right now, we'll just deal with this. Okay, so that's my indifference curve. What it means technically, I want to be as clear as possible on what it actually means. What it actually means is this line, this curve, represents different combinations of X and Y that will yield me the same ultimate utility. If, for example, we had a curve up here that ran like this, that would give me more utility, and it would be more combinations of the products. Okay? Down here, it would yield me less utility. To experience this much total utility, any of these combinations will yield that result. Now, you may have noticed in the table, and I've highlighted it a little bit more here, we're going to expand this. What this means is that you have what's called a substitution factor, or a sacrifice ratio is what we call it. Okay? We've seen this before, haven't we? We've bumped into this before. Where we bumped into this was back in Lecture 2. back in lecture 2, we talked at great length about the different advantages in economics. When we got to the discussion of comparative advantage, okay, what we dealt with was the amount of X activity that has to be sacrificed to do an amount of Y activity. Okay, if you remember any of those examples. And so the various workers that we looked at when we were dealing with comparative advantage, in order for them to give up doing one job, or in order for them to do one job, they had to give up doing a certain amount of another job. Same basic idea here. Now let's look at it. Here I start off at this level of the curve, 18 X's and 5 Y's. Well, in order for me to stay on the same indifference curve, but move up to the next point, I have to give up 6 units of X, for which I will receive 2 units of Y. With me so far? So 6X plus 2Y. I sacrifice 6 X's and get 2 Y's. Okay, now what do we see by that? In the next instance, I sacrifice 5 X's and get 2 Y's. Then I sacrifice 2 X's and get 1 Y. Then I sacrifice 1 X and get 1 Y. Then I sacrifice 1 X and get 2 Y's. Okay? Why is this? Well, it's something that I mentioned before. The more I have of something, the less valuable each of those things is. So when I'm sitting here with a whole bunch of X's, 18, and not very many Y's, only 5, the Y's are much more valuable to me than are the X's. I therefore am willing to sacrifice 6 of these X's to gain only 2 Y's. And that will continue, okay? And so what you have is a variable rate, a variable sacrifice ratio, a variable rate of substitution, what we call the VRS, okay? As I diminish the amount of X I have, each X becomes more valuable. And in order for me to exchange the next one, I have to get more Y in return, until ultimately I'm sacrificing 1 X and getting 3 Y's in return. Okay? And this is okay. I made an argument. This is the basic economic theory. I made an argument once with my brother with this. As I mentioned before in lectures, my brother is a pilot for United Airlines, and as a result of that, we can, if we want, as family members, fly on what's called a companion pass or a buddy pass, where it's a reduced rate, it's a reduced price, flying on the company. And a few years back, my wife flew to Louisiana, and we did it on a buddy pass, on a companion pass. After which my brother sent me a bill. He says, okay, this is what the companion pass costs. They don't know actually at the time you queue up for it. It's based on air traffic and a whole bunch of other things. But he says, okay, here's the amount you owe me, $150. And I went through, I developed a PowerPoint not unlike this one. And I went through a lengthy explanation in writing. I wrote him about a 15-page report on this, and I discussed it with him on the phone that because as an airline pilot, he makes about 5 times the money I make as an adjunct faculty member. Okay? He has 5 times more dollars than I do. What that means is that each of my dollars is more valuable than each of his dollars. The more you have of something, the less valuable each of them is. And so I said, and what we get from this is a basic exchange ratio. That means that one of my dollars is the same as 5 of your dollars. And so I said, I'm going to send you a check for $30. He didn't buy that argument. He didn't like that argument. But at any rate. Now, let's add to this discussion the idea of a budget line. Okay? This isn't dissimilar to something that we've seen before. Before, what we looked at was the linear equations for supply and demand, where you had it in this form. Okay, we should recognize this form from the previous lectures on supply and demand. You have one variable, the y variable, okay, equals an intercept, which is the value of y when x is 0, minus the rise over the run. Now we've reversed that here a little bit, but the price of X divided by the price of Y multiplied by X. Okay. Now we'll look at this when we get to the next example. But let's just throw some basic figures out here, shall we? Just real quickly. Let's suppose that product Y is $2. And let's suppose that product X is $1. Okay? And let's suppose that we have $20 to spend. Well, that means that if we have $20 to spend and product Y is $2, we can buy a maximum of 10 Ys. So this number would be 10. Because X is $1 and we have $20 in our pocket, we could buy a maximum of 20 of these. Okay? So that we can buy anything along this line for the same budget. Okay? Any combination that will yield that for us. From that, we get the basic sacrifice ratio like we dealt with just before. Now, let's go into an example. Let's say we start off here. Now, in this case, I've changed the numbers a little bit. I can change the numbers all I like. I can play with this all day and all night. Okay? We have an original budget of $50. Okay? Let's suppose the price of Y is $4 and the price of X is $2. Okay? This is just a multiplicative effect of what we just talked about. Okay? But at any rate, we won't worry about that. Let's take a look at this. Okay. If I've got $50 in my pocket, that's my budget. Okay? The price of Y is $4. So the maximum number of Ys that I can purchase is 12.5. 12.5 times 4 is $50. Okay? That attaches my budget line up here. Now what that means is that if I spend all of my money on Y, I can buy 12.5 and I can buy 0 X's. Or alternatively, I could spend all my money on X, $50. I could spend it all on X. X is $2 a throw, so I could buy 25 of them. Now, if I bought 25 of them, I couldn't buy any Ys at all. Or for my $50, I can buy any combination along this line. Okay? Now, what that means is that this is the maximum Ys I can buy minus what do I sacrifice? Let's look at this. Okay? The price of Y is $4. The price of X is $2. That means for every X I get, I have to sacrifice 1/2 of a Y. Every Y that I sacrifice is going to get me 2 X's. Okay? All right. Easy enough to understand. And we're back to this discussion. That's why I'm not spending an awful lot of time on it. We're back to this discussion of the sacrifice ratio, which we joined for the first time in the discussion of advantages. And we're going to look at this again and again as we change some of this stuff. We're going to change income. We're going to change prices. Okay. This is, and I mentioned at that time that when I was a kid, when I was a teenager, from the time that I was 15 till I was 19, I skydived. I jumped out of airplanes. And what they charged us was $1 for every 1,000 feet if you had your own chute. Okay? This established this exchange ratio. Okay? That's what you're dealing with here, is the same thing we dealt with before in an exchange ratio. 1Y equals 2X, 1X equals 1/2 Y. And that's what we have here. Okay? This is essentially the exchange ratio that you're going to get for X. For every X, you're going to get 1/2 of a Y. That's why we use it this way. We could invert this. If we inverted this, I'll just do it real quickly in my head. We would send X over here and have 1/2 X equals 12.5 minus Y. Multiply both by 2, and you would have X equals 25 minus 2Y. All right? Same basic expression. Same basic expression. Now let's increase our budget to $60. This is movement to the blue line. Well, obviously, we can just look at this and kind of intuitively grasp it, that if we now have $60, okay, we're going to be able to afford more. And so in this case, if we had $60, the price of Y is $4, we can afford a maximum of 15 units. if we have $60 and X is $2, we can afford roughly $30. Note that the slope doesn't change. The slope doesn't change because the prices of X and Y don't change. If we're changing income, then what we're effectively doing is shifting the demand line, much in the way we shifted supply and demand in lectures 3 and 4. In lectures 3 and 4, we shifted the supply curve and we shifted the demand curve. Well, it's kind of similar to what we're doing here. Okay, so when we change income level, we're shifting our budget line. Okay, we're not changing the slope at all. The exchange ratio of X and Y stays the same. All right. Now, if we, however, keep the budget the same, keep our income the same, but instead change the price of the products, then what we're going to end up doing is changing the slope. Okay? Now, for green, for example, which is our first, we'll decrease the price of Y to $3. For the same $50 budget, you can now afford 16.67. Okay? We can still afford the same number of X's. We haven't changed the number of X. So what that's going to do is change our exchange ratio. Because we now have a price of Y of $3, our price of X's stays at $2. For every Y we give up buying, okay, we're going to get 1.5 X's. To get a Y, to get 1 Y, we have to give up 1.5 X's, which would be 3 halves. Okay? And again, I'm kind of glossing over this because we've already looked at this. We're just, it's the same basic principle we dealt with way back in lecture 2, and again in lectures 3 and 4. Okay? We're just dealing with an exchange ratio. We're now just phrasing it in numbers. Okay? Same thing here. You know, with blue, we shift blue downwards. We have an increase of price of Y to $5. Okay? Again, notice that we're not changing the price of X. We could change the price of X as well if we like. Okay? This is ultimately, this part here, the previous slide is ultimately what we're going to talk about, and we'll talk about it at greater length as the income effect. This we're talking about is the substitution effect. When you're changing the exchange ratio, that's the substitution effect. The substitution effect effectively, and we'll deal with this again later, is how much of one thing I'm substituting for another. How much of one thing I'm sacrificing for another. Okay? And so when we deal with this, that's the exchange ratio. So you will note that when we change the price of the product, we're actually changing the slope of this line. We're changing the exchange ratio. In this second one, when we shift it down to the blue line, we've now increased the price of Y to $5. Well, for the same $50 budget, that means I can now only afford 10 Y's. I can afford the same number of X's. Okay? And what does it mean in terms of exchange ratios? Well, work it out in your head. Okay? The price of Y is $5. The price of X is $2. So for each Y I give up buying, I can get 2.5 X's. In order to get a Y, I have to give up 5 halves of an X. Okay? All right. And here's what I was just talking about. We're just going to run through this in the next couple of slides. We change X. Okay? Same basic principle. Now we're keeping the price of Y constant at $4. So for my $50, I can get 12.5, and we're just adjusting the price of X. Okay, so that's going to change our exchange ratio. If we drop X here, what we do is we drop X down to $1.67. Okay, and that works out to be this. Okay, we're just changing the exchange ratio a little bit. Now, here's the important part. Okay. We're going to put that indifference curve that we looked at and put it on our budget line, okay? Because what we had with our indifference curve was different combinations of the two products that will yield me the same utility overall. Now let's superimpose our budget line, and this is the budget line we've been working with, okay? For $50, we can afford 12.5 Y's, or 25 X's, or any combination along this line. Price of X is $2, price of Y is $4. Any combination along this line will be able to afford. How we're going to maximize our utility, maximize the benefit gained, is by finding a point on that indifference curve that is tangent, that has as a tangent the budget line, or that is tangent to the budget line, okay, that intersects the budget line. All right? Let's look at that a little bit more specifically. Okay? This is the indifference curve that we introduced originally. And remember how we went. This was the sacrifice ratio. This is actually a much simpler way to do it than the way the book did it with throughout the chapter with marginal utility. Okay, we'll look at that, and I'll let you judge for yourself which is simpler. I think this method is simpler. Okay, that's why I focus on it more. Okay, now let's look at this. This was our original indifference curve. Okay, we go down, we sacrifice 6 x's, get 2 y's. We sacrifice 5 x's, we get 2 y's. We sacrifice 2 x's, we get 1 y. Okay, etc. Now, let's remember, okay, or if you like, you can superimpose, you just remember in your head what the relationship in price is between X and Y. X was $2. Y was $4, which means you have 2 X's equal 1 Y. Well, if you look at this sacrifice ratio, it's a unique point. There is only one point where that's the case. When I move from E to D, okay, when I move from here to here, I sacrifice 2 X's, okay, which costs me $4, and get 1 Y, which costs me $4. You get the idea? And so we want to, the sacrifice ratio in terms of utility, okay, the sacrifice ratio of utility has to equal the sacrifice ratio in our budget line, okay? Or if you prefer, the slope of our budget line, right? And we can do it going the other way as well. Here we sacrifice 1 y and we get 2 x's. Well, that puts us in this area, all right? Now, let's now play with this indifference curve in our budget lines and shift the price of the 2 different products. And we don't have to do it an awful lot. We can just kind of take a look at it. If we change, what we did originally was what we do. If we change the price of Y, for example, okay? And we'll go over what happens if we change income as well. You can probably superimpose that yourself and see what will happen. But if we change just the price of Y, we increase the price of Y to $5. Okay, well, what did we say? We looked at this before. When we increase the price of Y to $5, we now can only afford 10 of those. We can afford the same number of X's, okay, down here at 25. We haven't changed that at all. So all we've changed is the slope. We've changed the sacrifice ratio. Well, we can look at the graph and see that based on the new sacrifice ratio, that since we increased the price of Y to $5, it's 1 Y is now equal to 2.5 X's. We look at that indifference curve and we notice there's nowhere along that indifference curve where the sacrifice ratio in utility equals the sacrifice ratio in money. Okay? And that's basically what we're doing. The sacrifice ratio in utility has to equal the sacrifice ratio in money. Okay? We have no curve there. So at this point, on this indifference curve, we can't maximize utility. Okay? The only way we could maximize utility is if we were willing to settle for less utility. If we were to shift this indifference curve downwards so that it was tangent along this line. Okay? Now, and just real quickly, if we were to change income levels, we would stick with this line and just shift it upwards and downwards. Okay? And we'll do that in a minute. Now, I make a subtle point here that the book doesn't make. See, this is one of the things that drives me crazy about this entire chapter in the book, is they've created an idealized model, and I understand the purpose behind that, But the fact of the matter is, it simply, it doesn't exist that way in the real world. Okay? It gets very close to that idealized model, but it never really hits that idealized model. And so, for example, I'll give you an example. Most people, myself included, I don't know about you, most people, when I go into a store, I very rarely walk out with $0. Okay? I either have a surplus, I haven't spent all the money in my pocket, or I have a debt. I have to put it on a charge card or a debit card or whatever. Okay? Well, the more likely situation here is I'm going to walk out somewhere on this indifference curve. For me to remain on this indifference curve, given the price increase in Y, for me to achieve the same utility, I'm going to have to incur a debt. I'm going to have to spend more than I have. I'm going to have to, in other words, I'm going to have to buy more Ys. Okay? In this case, to achieve D, if we remember, D was, I think, 10 units of one and 5 units of the other. Okay? Well, in that case, I'd have to incur a debt. Conversely, if we decrease the price of Y, for me to walk out with the same total utility, okay, the same basic sacrifice ratio in my indifference curve, I would actually realize a savings. I would have a surplus, okay? The difference between this point and this point, this would be my overall savings. Now, in this case, it just works out well that let's change the price of both, okay? And change income at the same time, okay? So this is an indifference curve with a price ratio and income change. If we change our income to $59, okay, we shift this line. Our original budget line was for $50. We shift it upwards. We now can afford 59 of them. Okay, we now have $59. Okay, we simultaneously increase the price of Y to $5. This means that we can afford a maximum of 11.8 Ys. Okay, 11.8 times 5 is $59. Okay, we can afford X if we keep X at $2. We can go from affording 25 of them to affording whatever 59 divided by 2 is. I think 59 divided by 2 works out to be 29.5. Okay? This is because of a combination of an income increase and a price change in one of the products. Okay? And it gets us to a point that we're gonna kind of conclude this overall lecture with in terms of income and price changes. And then that's what becomes critically important. Okay? Beyond the rather arbitrary idea of utility. Okay, and this kind of goes over what we've been talking about now, linking it back with our original discussion of the indifference curve. Okay, here was our original indifference curve. Again, we're sacrificing 6 and getting 2. We're sacrificing 5 and getting 2. We're sacrificing 2 and getting 1, etc., etc. Okay, now let's look at our price changes and our possible combinations along our budget line. We've increased our budget to $59. We've changed the price of Y to $5. Okay, what this means is it doesn't change the sacrifice ratio on our indifference curve. Okay, we're still sacrificing the same number of units, but it does change the point of utility maximization. The reason it's going to change that is because we've had a change in income and a change in the price of Y. Okay? It doesn't change our sacrifice ratio in terms of our total utility. The utility we're gaining from one by sacrificing the other. That's going to remain the same. That's completely insensitive to changes in price. What does matter is the price change in Y is going to change the monetary sacrifice ratio. What we could refer to, borrowing from lecture 2, is the exchange rate, the exchange ratio, or the exchange value. Okay, and we saw this before in this lecture. When we changed the price of Y to $5 and kept X at $2, okay, all of a sudden 1Y got us 2.5 X's. It became more valuable, okay, in its exchange ratio. When we, and by the same token, 1Y is now going to cost us 2.5 X's. All right. Well, now let's look at the sacrifice ratio in terms of utility to find something that's going to match that. Okay. If we look for the same thing in utility, what we notice is we've now moved down our indifference curve. Remember, in terms of total utility, it doesn't matter to us where on this curve, what combination we're purchasing along this curve. The key thing is to match some combination along this curve as a tangent to our budget line. Okay? Well, here, we're sacrificing 5 X's to get 2 Y's. Okay? That's 2.5 to 1. Okay? 5 X's for 2 Y's. Well, if we superimpose the monetary value, what did we say? X was, I think we said $2. Well, 5 X's is worth $10. 2 Y's is also worth $10. So we've achieved our aim here, okay, at 5 X's and 2 Y's. And so what we've done is, originally our combination, our utility maximizing combination, was 5 X's and 10 Y's. Now our utility maximizing combination is 7 X's and 9 Y's. Okay? This is ultimately the substitution effect. Because they've increased the price of Y, it becomes, to think of it in terms of utility, it becomes more frugal of us. It becomes more efficient, more rational, because they've increased the price of Y to hold more X's and fewer Y's. Okay? That's, I guess, the best way to really characterize it. We're going to look eventually at the most important of them all, which is marginal utility per dollar. Okay? What we're looking at here in terms of marginal utility per dollar is, if we look at X is $2 a piece, we don't have marginal utility. We'll need marginal utility to superimpose this. So we'll hold off till then. Now, a conclusion on indifference curves. Note that when the price increases, you need the same income to increase. You need an income increase to achieve the same utility. Okay, and that's going to get us again to this discussion, and this is kind of the critical discussion that we want to take away from this chapter in general. Okay, which is the wage price ratio and real income. All right, and read through it. We make a lot of we discuss at great length in macroeconomics the idea of inflation. Now, inflation, simply put, is a price increase. Okay, the reason that it's a price increase has to do with the exchange ratio of money. We won't deal with that at this point. Okay, but in point of fact, inflation itself, a price increase, what we've just seen, okay, based on this relationship of price increases and income, is that a price increase in and of itself doesn't really mean an awful lot. What matters is the relationship of changes in prices and changes in income. And it gets to one of the simple points that I made, I think, way back in lecture 1. In economics, money can flow in 2 and only 2 directions. Money can flow in and money can flow out. Well, for a consumer, the money that flows out is the price I'm paying for something. The money that flows in is the income that I'm making. Okay? That is where we derived the budget line from. The budget line and my income are the same thing. Okay? Those prices of X, prices of Y that got very confusing, that's my money out. So let's simplify it and think of it as money in and money out. Okay? And I need to balance that. Okay? And ultimately then what we got with utility maximization based on the indifference curves that we just went through, okay, is I have to balance the exchange ratio of utility, okay, on my indifference curve with the relative exchange of money going out. Money going out for one product has to be the same as money going out for the other product, given the utility I'm gaining for the products. Okay? We can think of it this way, too. We can think of it this way as well. Think of utility as the benefit gained. That's benefit, that's good coming into me. The price I'm paying for that utility is money going out. All right? Now, back to this wage price ratio thing. Price increases in and of themselves are of relatively little meaning, unless we also consider income changes, or wage changes if you prefer to think of it that way. So long as the wages rise or fall at the same rate as prices, your income stays the same. And I'll go through a numerical example of it in just a second. Okay? If prices rise and income stays the same, then you're worse off. If prices drop and income stays the same, you're in a better position. Okay, what we ultimately deal with then is purchasing power. Okay, how much I can actually buy, how much utility I can achieve given a certain income. Okay, now let's take a look at a numerical example of what we've been talking about with this wage price ratio. And I think this gives an example at a general level anyways, and at a group level. And actually we deal with this in macroeconomics as well, of consumer spending behavior. Let's say we start out, okay, with a wage or income or budget, however you want to phrase it, of $1,000. And the price of a product, or the price of all products on average, is $10. Okay. Now I've mentioned this before, this delta being change in. So purchasing power is based on this wage price ratio. Okay, we have $1,000, it's $10 a piece. Therefore, we can purchase 100 units. Okay. Now you'll note, first of all, based on this, and we don't need to work through the numbers on it. Okay, we can just think of it on a general level. Okay, if we increase the price, this number is going to go down. Okay, if we increase this number will go down. If we say instead, for example, that prices are $20, well, then we'll only be able to consume 50 of them. Okay, and that's going to explain to us why the demand curve looks the way it looks. Okay, as price continues to go up and my income stays the same, I can afford fewer and fewer and fewer of the units. Now, we're going to look at an explanation of the demand curve a little bit differently with marginal utility per dollar, but this is just as good an explanation. Okay, now, suppose now that we increase both wages and prices, which is what we did in the last example, is we changed our income level to $59 and changed the price from $4 to $5 of unit Y. And you can go ahead if you want some practice on figuring out percentage changes. You have a $9 increase in income and a $1 increase in price. The increase in price I can just do in my head real quick is 20% from $4 to $5. And let me just figure this out real quick while I'm sitting here on the blower, so to speak, by pulling out my handy dandy pocket calculator. And $9 is an 18% increase in wages. Okay, so we have a 20% increase in price. In that previous example, we have a 20% increase in price and an 18% increase in wage. And what we saw was that our ability to purchase product Y went from 12.5 units down to 11.8 units. Okay, we're going to look at the same thing here. let's say here that we have a wage that our wage increase, okay, we're going to reverse it a little bit and say our wage increase is greater than our price increase. So let's say that we increase wages, income, budget by 5%, and that we increase prices by 3%. Okay, therefore our new wage is going to be $1,050. That's a 5% increase. And the new price is going to be $10.30. That's a 3% price increase. Okay, hence 1,050 divided by 10.3, we can now purchase 101.94 units. Okay, and so this really gets us more towards this income effect idea. Okay, we can purchase more. All right. Real income went up as reflected in increased purchasing power. This will result in increased demand, which shifts the demand curve outward. Okay, because when we talked about income as a shifter of demand, without really explicitly stating it, we were talking about relative income or disposable income, or what we call in macroeconomics, what we call real income. Okay, this actually is what's going to be, like I bring this discussion into my macroeconomics courses. This is actually what's going to create the growth period. Okay, because as a result of this, we can now afford more products. So we're going to spend more money. It's going to shift the demand curve outward. That's going to create more demand. That increased demand is going to trigger the growth cycle. Now let's look at a situation where the change in wages, in this case an increase, is the same as the change in prices. Okay, let the wage increase be 4% and the price increase and the price increase be 4%. Now this is borrowing from the previous numbers. We're left with 1,050. Well, a 4% increase in that brings us to 1,092. And we were left with, what was it, $10.30. Well, a 4% increase in that's going to bring us to $10.71.2. Okay, you'll notice that our actual purchasing power hasn't changed. We've had a 4% price increase, but our purchasing power hasn't changed because it was neutralized or compensated for with a 4% wage increase. Okay, and so we've achieved a balance. This is consistent with both the peak of a business cycle and the trough of a business cycle from macroeconomics. Okay, so the real income was unchanged. Now let's look at, the opposite of what we originally looked at. This time, let's say the increase in wages is less than the increase in prices. Let the wage increase be 3%, price increase 5%. And we'll continue with the same numbers that we've been working with. Okay? And so from our previous figure, which was 1,090 something, a 3% increase is going to bring us to $1,124.76. From our $10.71.2, a 5% increase brings us to $11.24.76, $11.25. That's going to drop us back to that original 100. Okay, a decline in real income is reflected by diminishing purchasing power. So from 101.94 units to 100 units. As a result of the decline in real income, spending is reduced. This results in a reduction in demand with an inward shift of demand curve. And this is actually what causes a recession. One of the things that always drives me crazy. I'm sharing with you guys all the things that drive me crazy about economics textbooks. One of the things that drives me crazy is they talk about, in their discussions of macroeconomics, they talk about a recession, and they talk about it being a reduction in consumer spending, but they don't explain why that reduction in spending takes place. This is why the reduction in spending takes place, okay? Because there's a loss of purchasing power because of the wage-price ratio. Now let's look at another way of calculating utility maximization. And this is one that the book focuses most of its attention on, and I can understand why. It appears, from first glance, to be a simpler method, but it suffers from the problem that it requires an absolute amount, an arbitrary value for utility, which of course is a very difficult thing to ascertain. And so it has the semblance of being quantifiable without any of the substance of being quantifiable, which a quantitative person like myself, it drives me crazy. But at any rate, the basic principle, nonetheless, is theoretically sound. Okay, it makes perfect sense. What you want is the marginal utility, okay, the benefit you gain from the consumption of 1 unit of the product, okay, divided by the cost of that product, okay, divided by price, to equal the marginal utility that you achieve from the consumption of another product divided by the price of that other product. And you see a kind of a formula here. What this means is we're consuming products A, B, C, D, all the way through product N, which is the last of our products. What this means is that the marginal utility derived from A divided by the price of A needs to equal the marginal utility of B divided by the price of B all the way along through all of the products that we have. Okay? And this should, if we can keep this in mind next time you go into a grocery store, or next time you go in to purchase something, it will absolutely cripple you with the math, trying to figure out all of the marginal utilities and costs of everything and how much you're getting and all those things. Okay? Now let's look at an example, and this is an example that's drawn from the book. Let's say we have two products, apples and oranges. The price of an apple is $1. The price of oranges is $2. Here's our marginal utility. And this is our marginal utility per dollar. It's not difficult to derive. You divide the marginal utility by the price of the product. Okay? Which is to say a marginal utility of 1 divided by $1, we get a marginal utility per dollar of 10. Okay? We do the same thing over here with oranges. We have a marginal utility of 24. It costs us $2 to get that 24 units of benefit. So we get 12 units of benefit, okay, marginal utility, per dollar. Okay, what we need to be able to maximize our purchase is we need the marginal utility per dollar of this to equal the marginal utility of dollars for this. Okay, now we see there are several combinations where we can do that. Okay, we look here at this combination. If we buy one apple and 2 oranges, that does in fact give us the same marginal utility per dollar, which actually would be a perfectly reasonable utility maximizing combination. Okay, how much would that cost us? It would cost us $1 for this and $4 for the 2 units of oranges. So that would be for $5. Okay, we have another combination down here. 4 apples and 5 oranges. 4 apples gets us 6 units of benefit per dollar. 5 apples gets us 6 units of benefit per dollar. Note that we have marginal utility of 12, but you divide that by the price. Okay, well, how much would this combination cost us? $4 plus 5 times 2 is 10, so this would cost us $14. We have another combination down here, okay, where we have 7 apples with a margin, that 7th apple, okay, that 7th apple is going to get us 3 units of additional utility. Divided by $1 gives us 3 units of marginal utility and 6 oranges. Okay, now that would give us a marginal utility. That 6th apple, or that 6th orange rather, gets us 6 units of marginal utility. We divide that by $2 and we have 3 units of benefit per dollar. Okay, reasonable enough. What would this combination cost us? Well, $7 times 1 is $7 for the apples, and 6 oranges at $2 a piece would be 12. This would cost us $19. Okay, so you see, the more money we have, the more utility we can buy. Okay, and that's, we don't need lengthy explanations to explain that. The more money I have, the more benefit I can purchase. All right. Now, let's look at the substitution effect. And this is a little bit different than the example the book uses. In the book, they drop the price of oranges conveniently enough to $1 so that their model will work out perfectly. I don't do that, okay? Instead, let's increase the price of apples to $2 and take a look at where we are. Okay, so now we have the marginal utility of apples exactly as it was before. The first apple earns us 10 units of benefits. The second apple earns us an additional 8. The third apple, an additional 7. Okay, well, based on this, we have 2 combinations where the marginal utility of apples per dollar is the same as the marginal utility of oranges per dollar. Okay, we have this one, 3 and 3. Or 3 units and 3 units at the 4th apple and the 6th orange. Okay? Well, what would this combination cost us? This combination would cost us 4 apples at $2 a piece, that's $8. And 6 oranges at $2 a piece, that's $12. So this combination would cost us $20. Okay? Remember before we had the same basic combination, but it cost us much less. We have another combination here. Our 6th apple gets us 4 additional units of benefit at $2 for the price of the apple, gets us 2 units of marginal utility per dollar. Okay, same things down here. Okay, again, with oranges, that 7th orange gets us 4 units of benefit. It costs us $2, so we're getting 2 units of benefit per dollar. Okay, so again, now how much is this going to cost us? 6 for $2 is $12. 7 for $2 is $14. So this is $26. Okay, basically simple enough to understand. What we notice though is the substitution effect is the change in the price of the apple means that we can afford fewer of them given a given budget. Okay, we've dealt with the substitution effect before in this lecture. We've talked about it before. We're just kind of highlighting it again here. And it's a very complicated way of getting at a very simple, basic idea. Okay, and we get it actually in the law of demand. This kind of shows the derivation of the law of demand, not that it's terribly necessary, but we get it in the law of demand. Okay, the more you charge me for something, the less of that something I'm going to buy. Why? Because I have a constrained income. I do not have unlimited resources. Okay, this comes to us all the way back from lecture 1. Okay, from this scarcity of resources. If I'm on a limited budget, okay, and you raise the price of a product, I can't afford as many of it. I explained it, I think, more simply in the discussion of the wage-price ratio. I think that's a much more simplistic discussion of the same basic principle. Okay? Yeah. Now, the substitution effect explained, and we've explained it before. The price increase in apples means that apples yield less marginal utility per dollar. And that's ultimately what we're looking at here. Okay? As consumers, what we're interested in is not the total benefit I'm going to gain. It's the total benefit that I'm going to gain for the cost of it. We're going to get used to this. We've worked with it a little bit before. We're going to work with it again and again and again, especially when we get into our detailed discussions of supply. We want to get the most for the least. In terms of the consumer, we want to get the most benefit, the most utility for the least amount of money. We want to maximize our marginal utility per dollar. Okay? Now, if you look through those models we just looked at with that marginal utility, what you'll notice is that given a certain income level, the combination where the marginal utility per dollar of one item equals the marginal utility of another item, that's going to yield you your maximum total benefit. Okay? For that. All right. Now let's look at, and you know what? I'll explain that a little bit better here. Okay? But now let's look at this. Now we're back to it being the original. Apples are $1, oranges are $2. Okay? That was our original thing. So we said, okay, our first apple yields us 10 units of benefit at $1 a piece. That's 10 units of benefit, 10 units of utility for $1. Okay? That same 10 units of benefit for each dollar, we have to get 20 marginal utility units. We have to get 20 benefit units from oranges. Okay? This is because ultimately what this means is that apples, rather than oranges, apples are a better value for your dollar. For each dollar spent, okay, one apple gives you the same marginal utility for each dollar spent as 2 oranges. Okay? And so that's balance. Now what you'll see as we get on, if you remember our original combination, when we had a $10 budget, our original combination when we had a $10 budget was, okay, we have this point here and this point here, where the second apple yields us 8 more units of benefit, which is to say 8 units of benefit per dollar, because it's a $1 unit. Okay? Whereas with oranges, we come down here, we get 16 additional units of benefit for $2, which means that we're getting 8 units of benefit per dollar. So this was our original combination. And that original combination cost us $2 for the apples, $1 a piece for 2 apples, that's $2. And each of the oranges was costing us $2, and we bought 4. Okay? Now what you'll notice is that we have many different combinations. Okay? We have several different combinations. Given our budget, that's going to yield us the greatest total benefit. How do we get total benefit? Well, let's review here for a second. Total benefit is the summation of all of the marginal utilities, all of the marginal benefits. So, like, for example, the total benefit from the consumption of 4 oranges is 24 plus 20 plus 18 plus 16. And I numerically figured this out earlier on, and I think this was 44, 54, 62, 78 units of benefit from oranges, okay, and 18 units of benefit from apples, for a total of 96. Given that budget, given $10, you can't spend $10 any more efficiently, okay? My initial reaction is to say, oh, well, wait a minute now. Oranges yield more marginal benefit than do apples. So what if I blew my whole $10 on oranges only? Well, if I blew my whole $10 on oranges only, I could buy 5 oranges, okay? How much total utility would that give me? That would give me 24 plus 20 is 44, 62, 78. That would give me 90 units of benefit, okay? Try any combination, okay? 6 units of apples. Okay, that's $6, and 2 oranges. Okay, 18, 25, 31, 36, 40, plus 24 and 20. That's 44. That would give me 84 units of benefit. No matter what other combination I spend my money on, I'm not going to do as well as I did originally. Now, we want to look at what I found to be a very interesting point. Okay? What if we drop the income to $5? Okay, well, if we drop the income to $5, the combination that allows us to maximize utility is 1 apple and 2 oranges. Okay, the 2 oranges would cost us $4. The 1 apple would cost us $2. That would give us 10 units. You see that they're the same marginal utility per dollar. That would give us 10 units. Plus 24 and 20 is 44. That would give us 54 units of total benefit. Okay? Now, you see what we said. Well, yeah, obviously not. When we had $10, we got 96 units of benefit. Now that we only have 5, we get 54 units of total benefit. And therein lies a very interesting point. Okay? Now, instead of just thinking about it as marginal utility per dollar, let's think of it as average utility for everything we buy. Okay, let's think of it as average utility would be total utility gained divided by the total cost. Okay, and we'll deal with that in just a second. Now, here I ask a simple question. We're moving in the direction of these problems that you know I love so much. And then I suspect by this point you guys love them too. They're a lot of fun. Okay, what would our utility maximizing combination be if we raised income to $14? Okay, well, we look for other points on the line where the marginal utility of 1 equals the marginal utility per dollar of 1 equals the marginal utility per dollar of the other. Okay, well, we have this combination right here, which was the combination, if you'll recall, that we started out with. Okay, for $14. We have $14 to spend. Okay, so I look at this combination. How much does this combination here cost me? This is what you're looking for. Marginal utility per dollar equals marginal utility per dollar, 8 and 8. Well, this would cost me $2, right? Dollar per apple, 2 apples. This would cost me $8, so that's $10. Okay? That's not the best I can do. That's not the best I can do. Why? Because it's the best I could do for $10, but I'm told I have $14. Okay? So I'm going to buy myself 4 oranges, that's $8. 2 apples, that's $2, $10, but I'm going to have $4 left over. Now, we're assuming here that we want you to expend all of your income. In this case, I'd walk out of the store with $4 in savings. I'd have $4 left in my pocket, with which I could go and buy something else. A couple of orders of large French fries jump immediately to mind. I know, because of the McDonald's example at the beginning of this lecture, I now have French fries on my mind. Although they're not weighing so much on my mind that I'm actually going to go and get them. And that's something that we haven't built into any of our models here. I would refer to it, no economics textbook really refers to it. They do a little bit, actually. I would refer to it as the laziness factor. Okay, I'm sitting here giving my lecture. I'm doing other things. I guess it gets to opportunity cost. I really don't feel like going and getting all dressed and getting in my car and driving out to the local McDonald's to get some French fries. And so the marginal utility I would gain from such a consumption does not by any means get compensated for or be equivalent to the hassle of actually leaving my house. I'm finding as I get older, less and less and less is compensating me for the hassle of leaving my house. Now, eventually, I'll become some reclusive shut-in that does only online courses and never has to leave and can live the remainder of my life in PJs and have food and things delivered to me. But that's, you know what, that's a lecture for an entirely different time. What about for $19? Okay. Oh, well, I don't think we've settled the $14 one, have we? Okay. Well, let's look at another point. We have this point here. Okay. 4 apples. Okay. The 4th apple gets me 6 units of additional benefit. So that means 6 units of benefit per dollar spent. Well, that's, that equals buying the 5th orange. Okay. Can we afford this? Well, 5 oranges is $10. 5 times 2, that's $10. 4 apples at $1 a throw is 4. So for $14, this is going to be my utility maximization. And you can go ahead. You can go ahead and play with this and satisfy yourself. For your $14, go ahead and try any other combination on this chart. Okay? For $14, we could buy 6 apples and 4 oranges. Okay, you will not receive the same total utility, not marginal utility, total utility, as if you used this combination. Okay, and I know that's what's going to happen next time you guys go into the store. You're going to sit there and wonder about marginal utility per dollar to try to maximize your utility. That's what I do. That's why it takes me a lot of psychological preparation. Excuse me. When I go grocery shopping. Now, what about $19? Okay, and we could do this all day. I could say, okay, what about a $15 budget? What about an $18 budget? What about a $19 budget? Well, for a $19 budget, let's look at another point. Okay, what other points do we have? We had 8 and 8. We've dealt with that. That was $10. 6 and 6. That was $14. Well, look at this point right here. Okay, that's the only other point we have where the consumption of the 7th apple yields me 3 additional units of benefit at $1 a piece, is $3 of marginal utility, additional benefit, per dollar. Well, over here, that comes from the consumption of the 6th orange. Well, 6 oranges is going to run me $12, right? $2 a piece. 7 apples is going to cost me a buck each. It's going to cost me $7. So that's $19. And again, go ahead, look at any combination of items that you can buy on that chart for $19. You won't receive the same total utility. You will receive less total utility with any of them other than those two. All right? Now, that leads us to kind of an interesting train of thought that I kind of want to conclude this with. Okay, so, and we have to remember a little bit. You guys probably should have the PowerPoints in front of you, the printed out versions as we go through this to refresh your memory with what we've been dealing with here. Okay, when we had $10, our utility maximizing combination was 2 apples and 4 oranges. Okay, and that got us 96 units of utility. We were doing pretty well. That means that we were getting 9.6 units of utility per dollar. But then something happened, okay? Our income went down to $5, okay? Why did that happen? Who knows? Tax increase, payroll reduction at work because they're doing cutbacks, whatever, okay? At any rate, it dropped to $5. So what we looked at was when we had a budget of $5, our utility maximizing combination, and there was one apple and 2 oranges. This got us 54 units of utility for our $5. Up here, yes, we got a lot more utility. We got 96 units of utility for our $10. That brought us 9.6 total utility factors. The total benefit of 9.6 per dollar. Okay? Well, here, with only $5, we did much better. Okay? Which is a little bit counterintuitive, I suppose. We got 54 units of utility, which is less than our 96. But we spent a lot less money on those 54 units of utility. It was a much more efficient and frugal use of our money. We got instead 10.8 units of benefit, utilities, okay, per dollar. Interesting, eh? And it leads us to a conclusion. You don't always want to purchase more. What we're interested in is to now remember this, keep this in mind, we don't want to get confused. To maximize my utility, I want the last dollar spent on one commodity to equal the marginal utility of the last dollar spent on the other commodity. The marginal utility per dollar has to be the same. We're now looking at total utility per dollar. And when we look at total utility per dollar, we're not maximizing the total amount. But what we are doing is getting more for our dollar. Here, we're getting 10.8 units of benefit for every dollar we spend. Okay? Now, let's look at utility and value. This is kind of utility and value revisited. For $14, our utility maximizing combo is 4 apples and 5 oranges. We just figured that out a couple of slides ago. That gives us a total utility of 121 units. And it shouldn't surprise us. For $10, we got a total utility of 96 for our $10, which worked out to be 9.6 units of utility per dollar spent. Well, now look at this. $14, we spend more, we buy 4 apples and 5 oranges, which is more than we had before. Okay, so we think we have more. We think we're doing better. We have more overall benefit. But look at the price that we're paying for each unit of utility. Each dollar we spend is now only yielding us 8.64 units of benefit. Still more when we go to $19. Our utility maximizing combo here was, over here, 7 apples and 6 oranges. That gave us a total utility of 139. So again, we're getting more utility. We're getting more benefit. But ultimately, we're wasting our money. Okay? We're buying more and more and more, but it's wasting our money. It's wasting our money because we're actually getting less per dollar we spend. Okay? This is bringing us back to a point that we really kind of started this whole discussion with. Okay? This was a long way to get to a point that actually has already kind of been made. The conclusion we draw from this, okay, using the utility maximization principle, as our budget went up from $5 to $19, we got less utility, overall total utility, we got less utility per dollar. We get less utility per dollar as we buy more. Why is this the case? Let's look back at one of the original things. I think it was the second slide. Diminishing marginal utility. Each successive unit of a commodity yields us less utility. And therefore, because the price of the commodity stays the same, because each successive unit of the commodity yields us less utility, okay, each time, less marginal utility, it's going to yield us less utility per dollar. Okay? Which ultimately gets us to the more that we have, the less valuable each of those is in terms of its usefulness to us. Okay? And that's why, okay, so for example, if we've got 2 people living in the house and we have 3 television sets, that third television set is really kind of superfluous. It was really a waste of money to buy. Okay? Because who's going to watch it? What, am I going to watch 2 shows? I guess I could do that. I could have a wall of televisions and watch multiple shows all at the same time, which would be, I think, very distracting. Okay? So this actually gets us all the way back to our original point. And I want to stress it again. The more we purchase, the less of any given commodity, okay, the less valuable each of those commodities is going to be. Now, what we just found out in the previous discussion in the last couple of slides was it's not just per commodity. The more we buy overall, if we take all of the stuff we buy overall and add up the total benefit it gives us, the more we purchase, the less benefit we're actually getting per dollar spent. We get the most usefulness, the most benefit from the first dollar we spend. Okay, and so ultimately, this is an argument for conserving resources, for not buying more than you actually need. And I think that concludes this discussion of utility maximization and consumer optimality.